Okay. Let's see some Kotlin. How many of you work with Kotlin? Brilliant. How many of you have heard of Kotlin? Good. Goal is that when you leave, you all work with Kotlin. Can we accomplish that? No, I don't know. Right. Background to Kotlin. It started in 2010 by JetBrains, and at the time we basically were looking for a language. We've developed all of our tools primarily on the JVM. We've done some stuff on .NET, but everything that we do on the JVM is using Java. And we were looking for a language to cut down a little bit our code base, make it a little bit easier to work with some constructs, namely functional language, functional constructs, etc. And we looked around and there was two options. Both of the options really didn't serve us. One of them was Scala, because at the time Scala had performance issues. Tooling Scala is not easy. And our goals were something that was concise, expressive, toolable, interoperable with our code base, and overall pragmatic. So we discarded Scala for certain reasons, and our other option was Ceylon. But our focus a lot was around interoperability, not recreating module system, and our interests a little bit started to diverge with Ceylon as well. And that's when we came up with the idea of let's just write our own language, because why not? And it was developed from day one under Apache 2, and it was on GitHub. Now, some of you, if you've seen Kotlin, or you've seen a talk, or you've seen an article that says Kotlin is the Swift for Android, so the eternal question is, what came first, the chicken or the egg? I mean, what came first, Kotlin or Swift? Technically, if you look at GitHub, it was Swift. However, Kotlin was developed from day one on GitHub, whereas Swift was open sourced on GitHub just about a year ago. So we've been public from day one. The current state is that we released it in February 2016, although it's been put in production for many years. In fact, we've been running Kotlin in production at JetBrains for over 4 years, as have many other companies. Right now, there's about 20 plus developers full-time working on Kotlin. Our business model around Kotlin is to continue to sell our tools. So there is no kind of, long-term VC-backed venture here. This is not about consulting or creating frameworks around Kotlin, because it's about being interoperable. So we will continue to sell our tools, and that's our objective with Kotlin. We've got over 100 committers on Kotlin, which are between us and obviously people outside. And it's used now in 10 products at JetBrains, if not more. Any new product we create is with Kotlin. In fact, our new .NET IDE, which is .NET on the JVM, is written in Kotlin. External companies, Expedia, that we know of, some that we know of, NBC News Digital, Netflix, American Express, amongst others, are using it. Okay? Now, the purpose of the session today is to introduce you a little bit to Kotlin, but I'm going to do it in a different way. I'm going to build up towards getting to the ability to create DSLs, right? And DSLs are useful not when you want to create a full-blown DSLs, but concept of micro DSLs, small DSLs that can be used in different areas of your application for different purposes. Sometimes they can be for technical infrastructure code, sometimes they can be for business reasons, etc. And we're going to build up Kotlin. I'll show you the syntax, and we're going to build on and see how a series of conventions and functionality that we have in Kotlin allows us to reach something like this. And this is Anko, which if you're doing Android development is a statically typed way to create views as opposed to using XML. Okay? So we'll see how to get to this. So without further ado, let's just switch over to IntelliJ. Normally when I write code in a project, I usually use Gradle. Kotlin can work with Gradle, Maven, Ant, Command Line, NetBeans, Eclipse. We provide those plugins as well. IntelliJ Community Edition and IntelliJ Ultimate. For now, I'm just going to use the IntelliJ Ultimate Edition. And you can also see that I can target JVM and JavaScript. This is for the hipsters, right? Because every language now has to target JavaScript. We're also working on Kotlin native, okay? I'm going to target JVM. And I'm going to call it Seoul. And it ships with a very small runtime that actually is so small that you can use it in Android, and it's compatible with Java 6. That's why we had such a high increase of demand in Android. Kotlin was never made initially for Android. It was made for us to create IDEs, but you can use it for server-side tools, for Android, for any kind of thing. Finish. Okay? Now let's start writing some code. I can create a new file called Kotlin, and I'll call it main. What? Okay, one thing I have to change. Okay, you know what that is? That is, Kotlin is actually named after an island near the coast of St. Petersburg. And that's a picture my colleague took from a lighthouse in Kotlin, on the Kotlin island. It's more appropriate for this scenario, right? Better than the unicorns. Right, so let's write some code. First of all, I type main, that's my entry point. So I say hello print line, hello, hello. Run. It's got incremental compilation. Obviously, the first time it's a little bit slow. There you go, hello. That's getting up and running with Kotlin. You can even, like, you know, let's do a extract variable and say message and set a breakpoint and debug. And you can get all the debugging features, everything you've come to expect from IntelliJ, okay? Very easy to get up and running. So, first thing you notice, there's no public static void main because there's no class. It's just a function in a file. And any function that matches this signature becomes your entry point to the application, okay? Now, I can write functions. I can create functions. So let's create a function that says hello. And this one is going to print hello. Okay? I can call the function hello. What you come to expect. Very simple. The default return type for Kotlin is void. If you don't explicitly say it, it's void. But it's not called void, it's called unit. Why is it unit? Because unit is an object. What is an object? It's a singleton, essentially. Right? I can create a singleton. That's the singleton pattern implemented in Kotlin. It's called object. That's it. And then an object can have as many functions as you want, as many properties as you want. Okay? So I don't need to be explicit about this. I can create function with parameters. So let's create a function that adds two numbers, int y. First thing you'll notice is that we follow the convention of name of parameter, colon, and then the type. If anyone's ever done any Pascal, or Modular 2 or Delphi, you'll like this. Return type, integer. Return x plus y. Simple, right? If you want to do something as simple as that, with Kotlin, we're very much focused on writing as little code as possible, but keeping it concise and readable. Notice here, I didn't explicitly indicate the type inference, which will eventually come in Java. To do this fully, I would do something like that, right? But I didn't do it because the compiler can infer. It's the same with return types. If the return type is a single expression, I don't even need to write all this. I can just do x plus y, right? I can have optional parameters. So let's do z int equals 0. Now I could do add 1, 2. Or I could do add 1, 2, 3. I can make two of them optional. Now I could do add 1. I could do 2 and 3. Now, how do I know which one is optional if I only omit 1? If I omit 1, how do I know if this is the y or the z? Named parameters. Okay? What I was showing you in type hinting in IntelliJ for Java, here we have named parameters. So already I've cut down a lot of boilerplate code because I don't have to have overloads. I could just have functions with default parameters. Okay? So what else? One of the key things of Kotlin is the ability to do functional programming. which basically essentially could be translated into, let me treat functions as first-class citizens. If I want to treat functions as first-class citizens, I want to be able to pass around functions. I want to be able to pass functions to functions, or return functions from functions, which is also known as higher-order functions. How do I do that in Kotlin? I can create a function called higher order that, let's say, takes an integer and another integer, and then takes a function that takes an integer, and returns an integer. And this is going to return an integer. So what I'm doing here is I'm creating a function that takes an integer, and returns an integer. Am I going too fast? Yes? Okay. And what I'll do now is just invoke this function, passing in the parameters. Right? So all this is doing is, well, I need to return this. So all this is doing is just returning a function, the result of applying the function with the parameters passed in. Okay? Now, let's go ahead and call this function. Let me remove these two parameters so we don't get confused. Now I can say higher order, 1, 2, and I need to pass in any function that matches these arguments. So I can reference a function by name in Kotlin by just doing : and the name of the function. Okay? Very simple. I can create higher order functions with single parameters as well. Let's take this and we'll name it single, and we'll get rid of this, and we'll get rid of this, and we're going to just call function on X. So I could now create something like higher order single 1, and then let's create a function which is +1, right? So I'll say +1, and what that's going to do is return I + 1. Okay? So you can see here that I have now this +1. Okay? Now let me move this down here so we focus on the main. Let's get rid of all of this. Now, in Kotlin you have a convention in which you can drop the brackets. But before we do that, let me show you how you can also do this without having to explicitly create a function. You pass in a lambda expression, which is an anonymous function. To pass in an anonymous lambda expression, I can do 1 and then x + 1. Okay? A lot of type inference there. You don't have to be so explicit about things. Now, there's a convention in Kotlin in which if a lambda takes a single parameter, much like in Groovy, I can just reference it as it. There's another convention in Kotlin in which if a function has as parameter another function as the last position, I could also invoke it like this. And I can also do this. So you say, why, Hadi? Well, because I like to hit the enter key. How many of you are familiar with C#? In C# we have this thing called the using statement, which basically takes anything that implements the interface iDisposable, you do something with it and it makes sure that it disposes of it. Kind of like a closable in Java. Kind of like try with resources. In Kotlin we don't have using. Let's create it. Fun using object closable block, a function that takes no parameters and returns nothing. Try, call my block, finally, object close. Okay? Using my object, do whatever. This is going to be something that implements closable, for instance. Whatever, just let's ignore that for a moment. But you see what you're getting at. It kind of feels like I've just added a new keyword, so to speak, to the language, but I haven't. All I've done is add a new function. But the way that it allows me to express that function, the way it allows me to call that function, makes it feel like I'm actually extending the language in a sense, right? Now this is using, imagine if this was something like transaction. And I could have like a database transaction. And I could say do something and then like commit over here. Or roll back, whatever, right? You can start to create your tiny little DSLs that are focused around certain aspects of your code, and it makes it very expressive. Talking about classes. Class customer. That's it. That's how you create a class in Kotlin. Now that's a little bit useless. Let's give it a property. Well, name, string, well, email, string. I've just created a class that has two properties. This one is immutable. That means it can't be changed. Let's add a new one, ID integer. We can make this var, which means it's read-write. Val means it's not read-write. Okay? And I've also created a constructor. So if I were to create an instance of this, notice also there's no new keyword in Kotlin. I say 1 joe@gmail.com. Okay? Also notice there's no semicolon. Let's go ahead and print this. Ooh, ugly. Let's come here and add this. Ooh, nice. Just so you see what this has done, let me show you what this has done. Let's write some Java. Private int ID, private string name, private string email. And now, IntelliJ, help me. Okay? You compare. This has given me copy, hash code, toString equals, all by just adding data. Right? Now you say, well, big deal, Hadi, you just put yourself out of business because I don't need IntelliJ anymore to generate code for me. Well, hopefully that's why I do this after the previous session, so you see that IntelliJ does more than code generation. But more importantly, once you generate this, you have to worry about every time I add a property or a field, I got to regenerate, right? And beyond that, how do I know that the code that I have here hasn't actually been modified in relation to the default generated code? So I'm adding a whole bunch of boilerplate code to my code base for the single purpose of what? When I could just do it like that. Now, by the way, this is all completely interoperable. In fact, watch this. I'm in here. Well, let's go back to my customer main. Let's bring this up. Let's create a customer in Java. Val customer in Java equals customer in Java. Customer in Java get email. Notice that I can write this, but if I hit completion, it changes it to property. Because in Kotlin, we don't have really getters and setters. We just have properties. In Kotlin, you don't have fields. You just have properties. So when I'm using Java from Kotlin, I treat it as I would write idiomatic Kotlin. If I'm in Java and I want to use Kotlin, let's say customer customer equals new customer, one, whatever, whatever, right? Customer, I get email because it's expecting me to write Java. That's how smooth the interoperability is. Okay. Okay. Now, let's say that a customer is a person. So I'll create a data class person and I'll say customer. It says no, you can't. Why? Because by default in Kotlin, types are final. So you have to explicitly mark it as open. Now, I don't always want to do that. In fact, sometimes I just want to extend some class without having to create an inheritance chain, right? You can do that in C# with something called extension methods. You can do that in Kotlin with something called extension functions. So let's create some extension functions. Fun, string, hello. Print line, hello. Main, hello. Hello. I've just extended the string class with a new function called hello. Okay? Let's do something like fun, string, should equal value, string, this equals value, which is basically saying that the instance on which I'm extending this string equals the value I'm passing in, right? So one thing should equal the other. I can now do hello should equal hello. That's nice. Let's try something nicer. Hello should equal hello. Oh, wait, done. You add an infix. Any function or extension, member function or extension function that takes a single parameter, you can annotate it with, add the modifier infix, and you can call it an infix notation. Do you do BDD? Do you do testing? That looks nice, right? Much more fluent. Those are extension functions. Do you know what a big decimal is? It's a decimal that's big. Big decimal equals big decimal 1. Yeah, it's nice. I want this. That's much nicer. There. I've just created an extension property. Right? Let's introduce that to a variable, BD. So just like you can create extension functions, you can create extension properties. Nice annotation, right? Because I can use longer equals 100L to define what long is in Kotlin. Why not do something slightly similar, .bd, to represent what big decimal is? Yeah? It's more expressive. You get rid of this noise. You don't need that noise. Let's take it one step further. I'm going to show you something that's only available in Kotlin. Because a lot of other things, Kotlin is heavily inspired by other languages, right? I'm going to create a class called request. And that's going to have, for example, a query string. I'm going to implement Express.js or Sinatra or your favorite web framework. Query string, and let's say, for instance, val content type string. Okay? Class response, val status code, int var status text string. I'm now going to create a class called the root handler that takes a request and a response. Okay? I'm now going to create a function that I'm going to call get. And get is going to take a path, and it's going to take a function that takes as parameter a request and returns a response. And that, all it's going to do is return that function. So now I could do something like this. Get index request dot content type. That's nice. Okay, it's nice, but it's not great, because every time I've got to create this lambda. Yeah, okay, I could refer to it with it, but what is it? It's like, what is it? Baby, don't hurt. No, that's what is love. Anyway, let's do something different. Let's get rid of this. And let's pass in as parameter a root handler. But we're not going to pass in a root handler. What we're going to do is create a function that takes as parameters an extension function, which we call a lambda with receiver. Now, can anybody tell me what this will allow me to do? If, guess what? Since this is an extension function, it means I have access to what? To the class. What does the class have? The properties. What's the type for invalid media type? Tell me. 405. You don't know your HTTP status codes? Invalid media type. Although that's wrong, because this, shame on me, this should be accepts type. Okay? That's nice, but I'm not there yet. I would much rather have something like this. That's much nicer. But I'm not there. But we'll get there. Before I get there, let me show you something else. I have a class called manager. I create an instance of manager. I want to do manager something. So basically, I want to be able to invoke an instance of an object, an instance of a class. IntelliJ says, ooh, hit Alt Enter. I can now invoke an instance. How? You basically create a function called invoke and define it as an operator. And if you follow that convention, I can now do this invoke. And you'll say, what's this got to do with anything? Because we're going to use this exact pattern. Watch. First of all, I'm going to rename this manually. I'm going to call this status result, for instance, right? And now this one is going to be, now I'm going to create a new one, class response, that's going to have a property which is status result. Okay? So now, this doesn't work anymore. Let's uncomment this, and you see that that's going red. Create member function invoke. But this status result is going to be a status result, not a status result extension, just like we saw before. And magically, I got my DSL. And you can dive this in as deep as you want, right? Now the point here is that following just a couple of conventions that Kotlin has, and one of the most important things is the ability to create higher order functions that take as parameter extension functions, which we call lambdas with receivers, because it's got a receiving object. I can start to do things like that and create very fluent DSL, right? Getting rid of all the noise, and focusing on actually what I want my code to express. So an example of this is, if you're familiar with TeamCity, if not, you're going to be, because I'll show it in a moment. This is a DSL that we've created to define your build configurations using TeamCity. TeamCity is our continuous integration server. If you use, for instance, Jenkins, you might have used YAML. YAML is great for small builds. Once you get to a certain level of complexity, it's hard to express. We've created a DSL in Kotlin that allows you to create build configuration. And it's focused around what is focused. So I get completion, I get everything. Okay? So that hopefully gives you a general idea of what Kotlin looks like and how you can use it to create more concise, more expressive code. Cobalt is an example of using Kotlin to kind of create something similar to Gradle. Gradle recently announced their adoption of Kotlin. So now you can write your Gradle scripts using Kotlin, in addition to using Groovy. Spec is a framework that I've written, which is for testing. It's kind of like Jasmine or Mocha. There's also Kotlin Test, which is someone else has written, which has beautiful assertions using infix operators. So you could write should equal or should be greater than, etc., and so forth. Exposed is a library that allows you to use SQL with, again, a DSL without having to do all of that noise. Other examples, just look no further than the standard library. The standard library that ships with Kotlin has a whole bunch of functionality that is using these things, extension functions, to create code that you can express things in a more concise way. Coroutines in Kotlin. In 1.1, we're going to be shipping support for asynchronous programming. Now, many languages have one way of doing asynchronous programming. For instance, C# has the built-in way of async await. You decorate all your methods with async await. We didn't want to stick to a specific thing. So we built coroutines in general, and then we implemented out of the box in the standard library certain ways in which you can do asynchronous programming. But async, await, yield, all of these that are available in Kotlin, these are not keywords. These are not part of the language. They're just library functions. But you use them as if they were part of the language. Okay? If you want to learn more about Kotlin, go to kotlinlang.org. On trykotlinlang.org, you can try out some koans which take you through the language and show you the syntax. You can also download those from GitHub. And our Slack channel is extremely active. I think we've got close to 5,000 active users on it. Well, we've got 5,000 members, not active all the time. There's also books already. Here's a couple. One of them is Kotlin for Android developers that's targeted around Android. Kotlin in Action is by my colleagues Svetlana and Dimitri. That is now complete. It will be published very soon, but you can download it, you can purchase it now as part of the Manning Early Access program. I recently released an O'Reilly course of around 8 hours on Safari Online. So if you have that, you can also access the course. And that's it. Any questions?